The next assembly we're going to discuss is the Wilkins Model 550 and 550A series. This was a double check assembly produced under Wilkins' name. Actually, production began in 1975 under the name Richwell as the Model DC. Around 1978, it was sold to the Neptune Meter Company, who produced it as the Neptune Model 550. And Wilkins bought it around 1984-ish and began production until 1995 when it was discontinued under the Wilkins name. In the 3/4 through 2 inch sizes, it is a bronze-bodied piston-style check, as opposed to poppet or any other style. It's a little different than what we've seen in some of the other construction designs. The 2.5 through 6 inch was a cast iron body that was fused epoxy coated with the same piston design of check construction. Here's what the small 3/4 through 2 inch size looked like. It was a brass body construction, and in the original design there was a bolted check cover, first check pointing up, second check pointing down. Before it was discontinued, they switched to a screwed-in check cover design. The check assemblies, as I say, was unique because it was a piston style of construction, which is rather different than most of the standard poppet style as seen today. The check disc holder was around like a piston and went inside the check assembly, which acted like a bore of a piston, and the check assembly was guided by the body as it traveled up and down. That's the 3/4 through 2 inch sizes. The larger sizes, 2.5 through 6, utilized a cast iron body that was fused epoxy coated. Check covers were bolted on the top, first check pointing up, second check pointing down. The discs, the check springs were not contained on some sizes and were contained on other sizes. On the 3 inch size, the check assemblies were not contained. 4 and 6 inch they were in the double check. There we had a corresponding reduced pressure pencil version, model 575. So be careful when you're taking the covers off on the flange units. Some sizes had contained springs, some sizes were not a contained spring. Here's this schematic showing us the check assemblies. This happens to be rotated 90 degrees out of the passageway, but anyway, inlet check on this side, first check, second check pointing down. This was the contained spring units on the larger sizes. Again, some sizes the springs were not contained. Be very careful when you take the covers off for the first time. 3 or 4 bolts held the disc into the disc retainer. The spring tensions did not have to be removed on the contained spring units. Obviously, when we took the cover off on the uncontained spring units, it would come off. Wilkins also produced, and under the Neptune name also, the Model 550M series, and the M stood for manifold. It was one of the few engineered manifold assemblies. In other words, with this specially constructed Y-fitting, this Model 550 double check, and that specially constructed Y-fitting on the outlet, it actually was approved in that configuration from this end to that end as a backflow assembly in a manifold. Now, what was unique was, because of the special flow construction of this Y-fitting and the flow through the specific backflow assemblies itself, they were actually able to get the flows of a 6 inch by using 2 3-inch assemblies, and the flow of an 8 inch using 2 4-inch assemblies, and the flow of a 10 inch with 2 6-inch backflow assemblies in the same Y-fittings. So it was rather unusual that they were able to get those flow requirements through 2 of the smaller assemblies like that. Normally, to have enough area for a 6 inch, you would need 4 3s, not 2 3s. But they did produce, and it was approved as a manifold assembly. They did produce a Model 550 DCDA in the sizes 2.5 through 6, main unit being the standard 550 with the bypass assembly on there, being the Model 550 also, the small 3/4 inch. Same cast iron body, fused epoxy coated, and the the double check detector assembly, Model 550 DCDA. They also produced a Model 550 DCDAR, which was a manifold assembly, same as the 550 manifold, where they took 2 550 DCDAs and mounted them with that specially constructed Y-fitting to give it a manifold installation. The unusual thing about it was they used 2 3-inch to get the flow of a 6, 2 4s to get the flow of an 8, and 2 6-inch to get the flows of a 10. And that's the Model 550 DCDAR. They did produce a reduced pressure principal assembly in the Model 575, which utilized the same check designs as we saw in the 550. Relief valve mounted on the side of the check body, as you can see here on the 2-inch, having 2 external relief valve sensing lines. On the 3/4 1-inch, there was 1 external relief valve sensing line. But it was an RP assembly, again produced in sizes 3/4 through 2 inch. The larger sizes were produced in 2.5 through 6 in the cast iron fused epoxy coated body. Here's a breakdown of the 575 in the small sizes, the 3/4 through 2. Same check mechanisms as we saw in the 550, the piston style poppet design, piston style design with the cylinder as the body. The relief valve was mounted on the outside of the check body. 2-inch had 2 external relief valve sensing lines. The 1-inch only had 1. The relief valve on the small sizes 3/4 through 2 gave us a little consternation, Because there were several modifications made over the years. The 3/4 and 1 inch actually was made out of two different construction designs, one with a brass internal stem and the later construction out of stainless. And the 1 1/4 or 2 inch actually had 8 different relief valve stem designs that were produced over the years. Rubber parts would fix all versions, luckily, but there was concern when you went to repair it, when you'd open up, it would look totally different than one you'd seen before. The model 575 in 2.5 through 6 inch, just like the 550, was a cast iron body construction, fused epoxy coated. Relief valve was mounted underneath the check body, 2 external relief valve sensing lines on the 2.5 through 6 inch. Check springs were contained, again, on some sizes. 2.5 and 3 inch, the second check was not contained. The first check was. 4 and 6 inch, the checks were contained on the particular construction of that assembly. Same piston style design as we saw in the 15, as the 550, with the body acting as the cylinder or the bore that the piston travels up and down. Here's a breakdown of the 575 2.5 through 6 inch. Again, it's 90 degrees out of rotation. Inlet check coming through here. First check, second check. Same piston design as we saw in the 550s. Relief valve is mounted underneath the check body right here. The relief valve disassembled, relief valve seat, relief valve disc, stem, relief valve body. Our lower rolling diaphragm guide, spring, upper rolling diaphragm, and relief valve cover. And that's the 2.5 through 6 inch design of 575. They did produce a model 575 M series for the manifold as they did in the 550. Same story with the specially constructed Y fitting. And the 575, they were able to get a manifold assembly in sizes 6, 8, and 10. 2 3s were used to make a 6 inch manifold. 2 4 inch were made 8 inch manifold, and 2 6 inch were bolted together to make a 10 inch manifold. Again, specially constructed Y fitting, and the unique flow characteristics of the 550 and 575 with that piston check allow them to get the bare minimum flow requirements to meet the flow requirements in that manifold sizes. So that's the models 550 and 575. I'm kind of combined them together because we'll look at the check mechanisms when we're fixing the 575s, and we'll do that one in the small sizes 3/4 through 2 first, and then we'll go ahead and take the larger sizes of 2.5 through 6 inch apart. But again, through the different combinations, they were actually able to make a lot of different models, as you see, from a plain straight one to a manifold assembly, all by using that same basic construction. Let's see what they look like inside. Here's some cutaways of our models 550 and our 575 reduced pressure assembly, 550 double check assembly in the small size. Small size would be 3/4 and 1. They utilize the same type of check mechanism, so let's go ahead and talk about the checks first. Then we'll talk about the relief valve. It is a Y pattern assembly, but unlike the other assemblies that we've seen before, this poppet style, this is a piston style. What does that mean? Let's go ahead and remove the cover. Underneath the cover there will be spring tension. Cover comes off, check spring, and it's called a piston style assembly because the disc holder is guided by the body. In other words, the disc holder is like a piston that goes in a cylinder, and the cylinder is what guides the check assembly straight up and down. So piston style, meaning as opposed to poppet style where it has the post on the back through a guided mechanism, this one's actually guided by the body. Now, the problems with being guided by the body is obviously the body gets bent, damaged, or somebody puts a pipe wrench on it as they installed it. It would squash that, and if it squashed that body, the piston could not travel easily up and down through the check. So, this is the 550. Check seats are cast into the body, like here, as you can see. And this is the type of check assembly that was produced when it was discontinued. As I said, this valve was made for a lot of years. In 1975, it was made under the Richwell name. Neptune bought it around late 78, 9, something like that. And Wilkins has been producing it since then in that name. They did discontinue production of it, but the rubber parts are still available. All right, anyway, let's talk about the check assembly covers first of all. As you saw, what I took off is a 4-bolted bronze cover. The original version of this cover was a plastic cover like this, made of material that was a relatively hard plastic. And the problem is not that the hardness of the plastic, but it had to do with where the air bleed screw was. And what would happen regularly with the air bleed screw, unfortunately, is that it would strip or leak because it was strictly tapped into that plastic piece that, tightening the screw over the years to bleed the air out of the assembly, started wearing down the threads, and threads wore down and eventually were stripped, and then eventually it would just start weeping or dripping, and the cover started leaking regularly. So they replaced it with a plastic with a brass grommet in the center. Function of the grommet being stronger than just the threads on the plastic, hopefully they wouldn't have that problem. But because it was just pressed into the body, they still had a few leaking issues. So they went to the bronze disc holder, like I showed you here, and the bleed screw there, tapped it for that, and produced it like that for a while. It was a little more expensive for them, but they had less concerns with the plastics. And then at the end, they actually went to a threaded check cover like that. So you may find the threaded check cover, you may find the bronze with the plastic. One of those 4 check covers may be on this particular size unit. Now, as for the disc holder, this was the most common one and the one that was produced. One bolt holds the disc into the disc holder. But they did in the earlier versions make a bronze disc holder. And the bronze disc holder being very similar in dimensions to the plastic one. On the 2-inch there's some dramatic differences we'll talk about and when we get to larger sizes. But one of the problems they had with the brass disc holders is that they had a problem with friction. In other words, in a piston style check, if you under low flow it started rattling back and forth, it would cause enough friction that it would actually wear pieces into that body. So the thought process was to go to a softer plastic material that if it did rattle, theoretically we would not have the wear and tear inside the body. So you may find either the plastic version, or if it's a very old one, you may find the brass disc holders just like that. Rubber parts are exactly the same. Reassembly is going to be just the reverse. Cover sealed by an O-ring. Check cover back on top. Those are the check assemblies in the Model 550. And this specifically being the small, meaning 3/4 through 1-inch size. Now let's take a look about the relief valve that appear in the 575 series. Here's the 575 cutaway. Here you can see the screw-on covers. There's the same check mechanisms we just looked at with the plastic check assemblies. The 575 on the 1-inch size had one external sensing line, small little copper tubing that connected the high-pressure sensing line to the body. In order to repair it, we had to disconnect the tubing. Once we disconnect the tubing, we had to have 2 bolts to unbolt the relief valve assembly, and the relief assembly body had to be removed from the check body for a proper repair. So there were 2 bolts. And when I get the second bolt off, come on, there we go, you'll see we had the 2 bolts, but that's where our pressure sensing line came in. So right there where that little small hole is right there. The relief valve just mounted on the side and was mounted with a gasket. So let's go ahead and take the relief valve apart. The relief valve assembly on the 575, little, I don't want to say complicated, but a little different than what we're used to doing. The 2-inch gave us some variations. The 1-inch only had the 2 versions. It was either the stainless steel stem like you see here, or the brass relief valve stem, which I don't have a version to show you. But they did make it out of brass for a while, bronze out of it for a while. And go ahead and get the relief valve cover off. There will be spring tension underneath the relief valve cover once I take the cover off. Underneath the cover will be my relief valve spring, which sits on this little cap thing. And this is what holds my spring on top of the stem. Now you'll notice inside the stem there's a very sharp point in the center. In other words, it's not just a flat spring retainer, but it has a point there. On the top of the relief valve stem, there's an indent. Purpose of that is that I can take that pointed part, put it on here, and the way you could always tell it was balanced, it would spin just like that very easily. If it's off to the side like that, it won't spin, and it's not putting the concentration of the spring load on the center of the stem. So that was the purpose to have that like that, was that it would push the spring load directly on the stem, pushing it straight down and not cocking it to one side or the other. Next we have is a bolt on the top with a nut. So we're going to loosen the relief valve stem upper nut. There was a small washer, our upper diaphragm plate, our diaphragm, our stem O-ring, here, lower diaphragm plate. Now, once I've removed the top half, you'll notice that this brass all of a sudden turns to a black color on the side, inside the relief valve, and also inside here. Sometimes people will say, oh, look at the discoloration of the bronze. No, it's not a discoloration. It's actually a plastic coating that is sprayed on top of that stem assembly, the body of the stem assembly travels in, to make sure nothing sticks to it. It's kind of like having a Teflon coating. It's a plasticized material, but it's not Teflon, but it's like having a coating on there so that the materials, meaning the diaphragm, the 2 O-rings here and here, would not stick as they traveled up and down. So don't scratch off the black coating is why I'm telling you that. Anyway, once once I've got the top off, now I'm going to push down on the stem and it'll pop out from the bottom. It won't come out yet. Now I have to turn it upside down. Once I turn it upside down, what I'm going to see is my relief valve seat, and that's what's holding my stem into the body. To disassemble the Model 575, you need a 9/64 Allen head wrench. Usually one not in the common catch-all Allen wrench set, but 9/64 is needed to properly fix the 3/4 all the way up to the 2-inch size of 575 relief valves. So, good wrench to have in your hand if you're working on a lot of these. There are 3 bolts that hold, Allen head bolts that hold the relief valve seat in place. Once I remove those 3 seats, now the stem will come out of the body. And here you can see a close-up of that black plasticized coating on the relief valve body inside. Disassembling the relief valve stem. 1 nut on the bottom with the washer. Relief valve disc. Relief valve stem O-ring first. Relief valve disc, disc retainer, and relief valve seat. 2 stem O-rings. Rebuilding is a matter of taking off the O-rings and properly lubricating them, then reapplying them to our stem. We're going to go ahead and put our new relief valve disc with stem back on. Going to have our relief valve stem O-ring. Washer. And nut. Going to go ahead and tighten that up. Since it's an O-ring seal, we don't have to have it too overly tight. Back of the relief valve seat is an O-ring. Now we're going to go ahead and insert the stem in here, into the body. Now, that black area is kind of like a lubricant, but a lot of people start putting grease in here. Do not place grease inside that relief valve body, because unfortunately one of the problems, and oh, you can't see it because it's cut away, there'll be a small breather hole. There will be a small breather hole on the bottom of the relief valve body, which you can see on this one. And as the stem moves up and down, that's open to atmosphere, and that has to come in and out. And unfortunately, people will think lubricating this here makes this slide up and down better. Actually, it doesn't. It dries out because that's an air breather hole open to atmosphere. Anyway, so once we've got our stem in place, now we want to get our relief valve seat back in. We have 3 Allen head screws, of which I've already lost one, so it's a cutaway. I've got 2 to go ahead and tighten in to show you. Once I've placed the 3 screws, tighten the relief valve seat in, I push down on the stem all the way so it comes out through the top. Now we're going to reassemble the top portion of the relief valve stem. Now, let's take a minute how this operates. Earlier when we were talking about how the relief valve operates, we knew that it has to be an elastic element. We talked about trip ratios. There's a good trip ratio on this one, and it's hydraulically balanced. Those are those 3 variables we like to compare on our relief valve. But remember when we talked about relief valve stems, what does the movement? Well, the diaphragm is what moves in relationship to pressure changes in the body. But where does it direct that force to is some kind of relief valve seat or disc, which is way down here. So unfortunately, as we go to close that relief valve diaphragm, sometimes it may cock sideways like this, and if it does, it will definitely cause an issue on the opening of this relief valve. That's why it's critical that that relief valve stem has that point in the center that puts the load on the center of the stem, because we want to make sure all of the force is straight up and down and not cocked one way or the other. So why I'm saying that is, as we put this together, that's why it becomes important to make sure we put it together correctly. So let's go ahead and reassemble the top portion. We're going to have our washer on the bottom. We're going to have our lower diaphragm plate, our lower diaphragm plate O-ring, our diaphragm, upper diaphragm plate O-ring, upper diaphragm plate, relief valve washer, relief valve nut. Now as I go to tighten these 2 nuts, I want to be very careful, because if I just sat there and tighten this nut like this, what am I doing to the bottom? You can see it twists it. Now it's not an issue of twisting is going to hurt it, but it's not going to tighten. So what you have to do is you have to have 2 wrenches, one on this side, one on this side, and tighten them together to make sure that's tight along that stem. What you're tightening, as much as it's obviously an O-ring seal, so it doesn't have to be very tight, but you're assembling everything so it's at the proper height of the relief valve. After we've got the relief valve back together, go ahead and put the spring retainer on. Make sure you spin it like that properly so that you know that it's balanced in the center. Relief valve spring, relief valve cover, making sure you put the relief valve cover in the right place so that the sensing line will attach back up. And this is our 3/4 through 1 inch relief valve stem assembly. Now, connecting the relief valve stem to the body, there are 2 bolts, as you can see here, but more importantly is this gasket. And where that gasket has that small the small pressure sensing line comes through right there, it's critical that the gasket not cover that hole. You can see if I move that gasket up and down, it could unfortunately cover that hole, which would restrict my pressure sensing line. So put your bolts in, line the gasket up, make sure the hole is completely open. Then you go ahead and attach your 2 bolts attach the relief valve body to the check body. Once I have those on there tight, and this is a gasket seal, not an O-ring seal, so tightness counts. Once I have the tight on there, go ahead and attach our copper tubing for our RV sensing line. You don't see it here because it's cut away, but there is an air bleed on the top of the relief valve cover. Critical, positively, every time you fix this, make sure you bleed the air out. This particular model, more than many others, has a concern getting air out of the top, the covers, and the checks in the relief. So make sure you bleed air out of this valve, especially very well when you go ahead and turn it back on. And that's the model 575 and a 3/4 inch. Let's talk about the 1¼ through 2 inch sizes. I have a 550 here in my hand. Bronze body, just like we talked on the 3/4. This is a true 550 because you can see that where the relief valve mounts is not tapped, and that was the only difference. This was used for a double check. When they drilled and tapped that to mount the relief valve on the side, that was used for the 575. Anyway, another valve that had to be visually identified a lot of times because there was a tag made out of aluminum that sat right here that used to sit right there, as you can see, and there's no way to identify this assembly. The old days, they would just put a small tag with a couple rivets in it like this. Unfortunately, the tag would be out of some material that would corrode away relatively easily, just like this, and you'd have no way of identifying it. Anyway, back to the checks. Same check mechanisms as we saw in the small 3/4 and 1 inch. It is a piston style check. Piston as a piston with a cylinder. 4 bolts hold the check cover, check spring, and then the check disc holder, which looks like this. Now, this is the disc holder that was produced when it was discontinued. Some of the earlier versions utilized a check disc holder out of brass, just like the 3/4 or 1 inch size did. But I mentioned earlier on the smaller size there were some differences and it had to do with these parts right here. Notice the thickness of the disc holders. On the old bronze one, it was relatively smaller. On the plastic one, it was much thicker. This is actually the guide of the check mechanism. Think about it. If this is a piston going in and out of a bore, what causes problems when it rattles sideways? So by making these longer, like here, versus here, and same here, now suddenly it's a more stable check if it's a bigger area. It had to have hollow through the center here for the water to travel, but as it moved back and forth like that, by having a wider front edge like you see here on the plastic and on the brass, and the back edge, made it so that it didn't tip as much as it traveled, making it a more stable through its check design. But either one might be in the assembly. You might find the plastic ones and you might find the brass ones like that. One disc holds a disc into the disc holder. Reassemble. Do not grease the body. Because it is a piston, a lot of people say, oh, if I put grease through here, it'll slide up and down better. That is not true. Like all backflow assembly is designed to be self-cleaning. Like all backflow assemblies, it is built so that water will jet around here. You can even see the V-ports in the back side of the disc holder. On the brass one, they actually had large holes in the center like that to allow water to travel through it to help it move up and down. So no grease on the body. Check spring. Make sure that the cover with the air screw is at the top. You can put it on the bottom, obviously, but you're never going to bleed any air with it. So O-ring seal on that check cover. 1¼ through 2. Very similar in construction to the small 3/4 and 1. That would be the model 550. Same check mechanisms in the 575, just different spring loads.